Hi friends, welcome to Geeks for Geeks. This is a video tutorial on how to find the longest Bitonic sequence. Let's look at the problem statement. Given an array containing n positive integers, a subsequence of array is called Bitonic if it is first increasing then decreasing. Write a function that returns the length of the longest Bitonic subsequence. A sequence sorted in increasing order is considered Bitonic with the decreasing bar is empty. Similarly, decreasing order sequence is considered Bitonic with the increasing bar is empty. Let's look at some examples. If the input array is 1, 11, 2, 10, 4, 5, 2, 1, then the output will be 6. The longest Bitonic subsequence is of length 6 and the sequence is 1, 2, 10, 4, 2, 1. If the input array is 12, 11, 40, 5, 3, 1, the output will be 5 with the sequence being 12, 11, 5, 3, 1. This is a decreasing Bitonic subsequence with the increasing part is empty. And if the input array is 80, 60, 30, 40, 20, 10, then the output will be 5 with the Bitonic sequence being 80, 60, 30, 20, 10, again decreasing. Now let's look at the solution. This is the variation of the standard longest increasing subsequence LIS problem, which has been covered in another video. It is highly recommended that you watch that video first. We need to construct two arrays, LIS array and LDS array, that is the longest increasing subsequence and the longest decreasing subsequence array, using the dynamic programming solution of the LIS problem. LISI stores the length of the longest increasing subsequence ending with array I. LDSI stores the length of the longest decreasing subsequence starting from array I. Now, from both the arrays, we find LISI plus LDSI minus 1 for each value of index I. As LISI gives us the length of the longest increasing subsequence ending at array I, and LDSI gives us the length of the longest decreasing subsequence starting from array I, so the overall length is that of the Bitonic sequence, which is first increasing then decreasing. We subtract 1 as array I is counted twice in this subsequence. And finally, we need to return the maximum value of LISI plus LDSI minus 1. Now let's look at the implementation. Both the arrays are initialized by 1 as a single element itself is an increasing or decreasing subsequence of length 1. To compute the LIS array, we calculate the length of the longest increasing subsequence starting from index I, and for each index we run another loop from j equal to n minus 1 to I, where it compares array I with array j. If the value of array I is greater than array j and the value in the LIS array at the ith position is lesser than the value at the jth position plus 1, then we have LISI equal to LISJ plus 1. Similarly, we fill the LDS array, except that the loops run backward with I going from n minus 2 to 0 and j from n minus 1 to I. After that, we calculate LISI plus LDSI minus 1 for each value and return the maximum of it. This would get clear as we look at the illustration. The time complexity is going to be order n square as there are two loops in it. Now let's look at the illustration. The input array is 1, 11, 2, 10, 4, 5, 2, 1. We'll calculate the LIS array and the LDS array. Then we will calculate LIS plus LDS minus 1 for each value and return the maximum of it. Initially, both the LIS array and the LDS array are set to 1. Refer to the video on the LIS problem and we fill the LIS array this way. Now let's see how to fill the LDS array. We start at I equal to n minus 2, so I equal to 6 and j equal to n minus 1 equal to 7. Array I is greater than array j, yes, as 2 is greater than 1. And also, LDSI is less than LDSJ plus 1, so LDS of 6 becomes 1 plus 1 equal to 2. Now let's see how, now I will be equal to 5 and j will be equal to 7. 5 is greater than 1, so LDS of 5 becomes 1 plus 1 equal to 2. Then we update the value of j becomes 6. 5 is again greater than 2, so LDS of 5 becomes 2 plus 1 equal to 3. Then I and j are again updated, I becomes 4 and j becomes 7. LDS 4 is greater than 1, so LDS of I will be equal to LDS j plus 1. So this becomes 1 plus 1 equal to 2. Then j becomes 6. 4 is again greater than 2, so this will become 2 plus 1 equal to 3. Again the value of j is updated, but this time 4 is not greater than 5, so no change. Similarly, we fill the entire LDS array, and this is the final LDS array we have. Now we have our LIS array and the LDS array. We calculate LISI plus LDSI minus 1 for each value, and we obtain this array. The maximum value is 6. Hence, the length of the longest Bitonic subsequence will be 6 for the given input array. Thank you for watching. Please leave us your likes and comments.